Yeah, welcome back from a well-earned coffee break after a long day. We've had a lot of sessions today on subsurface, on-surface developments, offshore wind, and we started with a story about the future of the North Sea. And we start off with a student pitch by Ryan Mostert and Berber van der Steen. So I'd like to ask you on the stage, please.
Yeah, thank you. So welcome everybody. I hope you all had a good break and some energy left for the last session of today. First I will introduce ourselves. This is Ryan Mostert. He's studying as a mechanical engineer. My name is Berber van der Steen and I'm studying as a naval architect. And we're both doing the minor Waterworld at Hogeschool Rotterdam at the moment. And today we are going to tell you what we researched for the last 10 weeks. So first of all, I will tell you about the idea behind our minor. It is based on a project from TNO about power to gas. Then we will tell you about the future perspective, and it's split up in 3 courses, which is the design of a hydrogen platform, the design of an offshore wind farm, and the design of a floating wind turbine. So first of all, the case of TNO, there's a lot of energy made at the North Sea by wind farms, and one of the solutions is to store this in hydrogen gas, and we are busy to design a hydrogen production platform at the North Sea. There are a lot of oil and gas platforms at the North Sea, and within a few decades they will be out of use. So you can decommission those platforms for millions of euros, or you can reuse them to build a hydrogen platform on it. So all the students get a specific location at the North Sea, and we researched the weather data at that location, and then we designed an offshore wind park. Then we looked into the future for deeper waters to design floating structures for the wind turbine, and of course we designed a platform to store this in hydrogen.
Yeah, so all students were, like groups of students were given certain cases, some for designing a wind park and designing a platform for hydrogen production. And we've got a few examples over here on the screen, and the first one is the wind park. This one is a wind park of 16 Edmund turbines of 8 megawatts, also created to supply energy for the platforms. And one of the examples of a hydrogen platform could produce over 800 kilograms of hydrogen gas every hour when working optimally. Now, these numbers are very clear, but what do they mean? So, we are engineers, we like numbers, so for a better perspective, we can produce quite a bit of energy for a lot of households like this when producing optimally. And this 800 kilograms can transform into 70,000 kilometers with a hydrogen car, which is quite a lot for considering the project. Now, what we see here is one of the examples of a case. On the right top, we see a platform of Wintershell, the LAP4 platform, still in use. It's a gas platform used for gas compression and treatment. But we were like, okay, maybe we could rebuild this when it's out of commission and create a hydrogen production plant on it. So on the left is the new refit of the platform with all hydrolyzing equipment on there. So the machinery required for splitting water into hydrogen gas and oxygen, which requires the energy from the wind park. And like this, there were many more platforms for specific locations, and all of those were transformed, basically. What we see here is an example of the wind park. So this is the 60 turbine Edmund park, also used to supply the energy to a platform. So what we see here is the 3 main lines towards the platform itself. And this park is placed on monopiles or jackets, so it's on solid structures. In the North Sea, that's for most locations, it's very viable. But in the future, when the North Sea gets more crowded, you gotta move further out of shore, you're gonna get deeper water, so you're gonna need floating structures for those. Well, that's another thing we investigated. So on the right here, we've got a more traditional way of using a floating structure. This is a spar. And this is already in use around the world. So this is a proven technology, already used like in many countries. And on the left is a more outside of the box idea, also created to place multiple turbines on a single structure. Also to improve several things like maintenance and just feasibility of a park. Now all of these things together should create a total network that could create a lot of hydrogen for us and could maybe clear the deficit between supply and demand of energy. So it takes a lot of engineering, and that cannot be done just by students. So we need many more people, many more companies, and many more parties involved to get this done. So energy transition needs you, needs all of you, as a country, as companies. I really would like to thank you for your attention, and we hope we've created a bit of more insight into hydrogen possibilities and energy stores in gases. Thank you.
Thank you very much for a very interesting presentation. And I'd also like to thank you for already the bridge you're making to the networking drinks. I don't know if it was a challenge to find you at the floor there. There's a lot of companies here that might have interesting ideas or questions for you. So feel free to approach each other there as well. And thanks a lot.
Thank you.